Okay, we're in section. Nope, wrong notes. I got to get to the right notes now. Give me 1 second. Close that out. Close that out. Just be patient with me. Get the right notes here. We're in 122, right? And we're in section 10, which is the partial fractions. And I'm going to be talking about the related Sage code now. All right. Let me just remind you that you can still use the interactive version. And that's the interactive version on the sagemath.org website. And you're more than welcome to do that. It's CoCalc. All right. The only difference between what you're doing on CoCalc and what I'm doing on my machine is my machines are doing the computation. When you go to CoCalc or the sagemath.org site, they're doing the computation for you. Nothing to do with your computer. There's a problem there because they may not be able to give you the resource that you need to do a problem. On my machine, though, it's the resources that my machine are providing to me. The other difference is I hit return to execute command on CoCalc, it's shift return. If you have any issues related to what we're talking about, you should feel more than welcome to come by and discuss it with me. All right, so let me go to my instance of Sage and give you a moment to do that. Let me clear the screen so you don't see that there. And I'm just going to start typing this stuff in. And again, the point of this is just to probably just learn a little bit, right? So reset, X is a variable. Again, we'll talk through this in a moment. Reset basically clears the memory out that I have my prior problems. I'm defining a variable X. It's actually a default in Sage, but it's really a good practice to get into is just defining your variables before you use them. And then I define a function f of X. I'm assigning f of X 1 divided by X squared minus 1. And then what I'm going to do is I'm going to take the function f of X and I'm going to ask Sage to take that function and partial fractions. P-A-R-T-I-A-L, fractions. And let's just see. I don't think I need the X there. Whoops, I guess I do. You know what? I'm having a little bit of a problem here. I got to take a look at what I got over here. I probably typed it wrong. Oh yeah, I see it now. Partial fraction. I was saying partial fractions. All right. So it does it. Have we done that problem before? Yeah, we did. All right. So I'm going to look through this and realize there's another function over here. I'm going to do a copy paste. Let me clear the screen for you now. Let me display f of X for you. What do I do with f of X? Partial fractions again. P-A-R-T-I-A-L, fraction. And it does a partial fraction. Have we done that before? Of course we have. All right. So you see that this is a bunch of partial fraction stuff over here. And, certainly what I want to do is I want to go back to the notes. And what I want to do is go back to some of the problems that I thought were, kind of difficult. All right. And see if I've learned any lesson from me looking at that Sage code. All right. And I think the problem that we were talking about that I thought was like really kind of difficult was this problem over here. So let me do this over here. I'm going to clear the screen. And I'm going to type this in. So I'm going to say f of X is going to be assigned 4 minus X divided by X times X squared plus 2. I think if you recall back to me doing this problem, it was problematic. There was no doubt about it. All right. And let me see how I did with that. I'll just type in f of X if I typed it in right. Let's see. They were a little differently. Yeah, it's fine. It just factor out -1. Yeah, I did all right. And let me do the partial fractions now. So again, if you can't remember, you could always go back over your entries and look what you did. And we did that, right? Remember? All right. So the question is, did it do it? And, the question is, it did do it. And was it quicker than we did it? Yeah, a lot quicker. But are we getting 1 over x? Yes. Are we getting minus x over x squared plus 2? Yes. Are we getting the subtraction of 2x plus 1 over x squared plus 2, quantity squared? Yes, we're getting all that. All right. Now let's do the integration now. All right. I want to see if it does the integration. All right. So again, someone says, can I do it by hand? Of course you can, but let's just see if we can integrate. Again, the point of this is not to do it using Sage, but to learn how to work Sage. Now, let me just look at, I know it's tough looking at these things over here, but looking at it, one thing I want to point out that Sage doesn't bother with the absolute value, but let's take a look at it. Minus 1/8, square root of 2, arctan. Yeah, I'm seeing that. Let's see, x minus 4. Well, they're combining two terms together. I do see that. Yeah, I'm seeing it. And then did they see this one over here? Yeah, I'm seeing that one over there. And I'm seeing log. Yeah, they don't use the absolute value. The only thing that's missing over here is the absolute value symbol and the constant C being added on. But I do notice that they added these two terms together. All right. So someone would say, is that something that I should be paying attention to? Yeah, you need to learn how to do Sage. All right. Let's do this one over here. And I'm going to do partial fractions now. And let me type this in for you. This is 1. I want to see what it does. Well, let me assign the function to f, okay? F of x is going to be assigned 1 divided by x squared plus 2 star x plus 8. And we did this one in class. I'm going to do that partial fraction business again. Doesn't do it, right? Let me do the integrate. It does the integration. And the question is, give us the same integration. Let's take a look at it. Again, I might write a little differently than we have it written down, but the bottom line is an equivalent statement. It is an equivalent statement, by the way, just missing the constant of integration. And that's typical computer algebra system. They don't throw it in, right? I want to briefly go to Wolfram alpha, right? Because I know a lot of students that I've spoken to, they find Sage to be very difficult to deal with. And they say, well, I want to use alpha, and there's nothing wrong with it. Wolfram Alpha's commercial software. And what I want to do is I want to, look at a problem. And I want to see how Wolfram Alpha handles it. And let's go back to this one over here. And I'm going to just simply type in, natural language, partial fractions. And it's going to be 4 minus x. See how it does. The more tools you have at your disposal, the better. Dividing by x times x squared plus 2 quantity squared. See how it does. One thing I like about Wolfram Alpha is going to typeset it for me. And then it puts down the partial fraction decomposition for me. Let me see if it can integrate. Again, I'm just going to type over this, integrate this thing. And if you want to, you can say with respect to x, but you don't have to, WRTX. Again, I'm looking for the typeset version of it. And I'm seeing over there. And I do see them putting it out. Now, as soon as you say, well, if a machine can do that, why do I need to learn to do that? And I want to warn you about this. You're never going to get to the machine level unless you can do things by hand. You'll never be able to formulate a problem. It's just not going to happen. So what are we doing over here? We're learning something about basic skills, and those basic skills will hopefully translate into being able to solve problems. But eventually, a problem gets so difficult, you're going to have to use a machine to do it. All right? It's no way around it. Use a machine. So, I'm looking at this over here, and I grant that you might say, oh, their answers look a little different than mine. Not substantially so. They might do some simplifications. I might do some simplifications, bottom line. I also want to point out in Wolfram Alpha, they give a lot of information that some students believe is being extraneous. You may want to look through that. It almost reminds me to go to Wikipedia. I want to do that now. And I'm going to type in partial fractions. And look, it comes up. Look at that. And someone's going to say, this is, it's a lot of information down. And it's so true that you might say, all this stuff is, your notes only had, less than a page written on it. And if you look at this thing over here, I mean, they really just go on and on and on. Then they give examples and things like that we do. And I want to point out, it's not a bad place to be going. I know some of your teachers are always saying, oh, Wikipedia, don't use Wikipedia. I'm a big fan of Wikipedia, and I would recommend that you consult Wikipedia. The problem for lessons for Wikipedia, though, is the detail that they give you, right, might be overwhelming to you. And certainly what are people trying to do when they're learning? They're trying to really boil things down to a much simpler approach, which is what I'm trying to do in class by giving you short lectures and then examples that specifically speak to what we're doing in lecture. All right. Now, granted, some of the questions in the example is difficult. One of them was, but otherwise they were pretty straightforward problems. They really kind of represented exactly what we said in the lecture part, and lectures are real short. All right. All right. So that's all I wanted to basically say about this section over here with respect to SAGE and the partial fractions decompositions. Thank you for your attention.